Hello guys, and welcome back to another video where we are going to be going through another maths worksheet which aims at grades 6 to 9 focus at GCSE. Question 1 asks us to solve the equation 5x minus 9 equals 26. So what we do here is we're just rearranging to get x. So in the inverse of minus 9 is plus 9. So we have to do the inverse plus 9 on both sides to get 5x equals 35. Now the inverse of 5x would be to divide it by 5. So now we have to do divided by 5 on both sides. So 35 divided by 5 equals 7, meaning our final answer is x equals 7. And there we go, we've solved the equation. Question 2 asks us to expand and simplify x plus 5 with x minus 7. Okay, so first of all, let's expand it. So x plus 5, x minus 7. So x times x equals x squared. X times minus 7 equals minus 7x. 5 times x equals 5x. And then lastly, 5 times minus 7 equals minus 35. So we've expanded it there. Now it's time to simplify it. So you can see here that we've got like terms of minus 7x and plus 5x. So we can simplify that and just do minus 7 add 5 to get minus 2x. So our final answer would be x squared minus 2x minus 35. So there we go, we've expanded it and we've simplified it. Question 3 asks us to factorize completely x squared minus 10x plus 21. So this is a quadratic equation, and in terms of factorizing it, we need to find two numbers which add up and give us a sum of minus 10, and when multiplied together give us the product of 21. So what two numbers could we use here? Well, we could use minus 7 and minus 3. Why? Because minus 7 add minus 3 equals minus 10. And then minus 7 times minus 3 equals 21, because two negatives when multiplied together give us a positive. So when we factorize it, we can put it back into the bracket. So x minus 7 and x minus 3. And there we go, we factorized it. Question 4 asks us to solve x squared equals 81. So we just have to do the inverse and get x on its own, just like how we done in the first question. So what is the inverse of anything squared? Well, it's the square root. So in terms of getting x on its own, we have to do the square root of 81, which is plus minus 9. So the answer would be x equals plus minus 9. Question 5 wants us to work out the value of 2 squared times by 5 cubed divided by 10. So 2 squared times by 5 cubed divided by 10. Okay, well, 2 squared equals 4, so we can rewrite that as 4. 5 cubed equals 125, so we can write that as that, and then divided by 10. Well, what is 4 times 125? Well, 4 times 125 is just 500. So now we're just left with doing 500 divided by 10. And what is that? The answer is 50. Question 6 asks us to write 0.0073 in standard form. Now when using standard form, the number you multiply the power of 10 by must be between 1 and 9.9. So in this case, the only number we can create here is 7.3. So you could put the decimal place there. So 7.3 times 10. And now we have to work out the power of 10. Well, when moving the decimal point, you're moving it to the left. So you know it's going to be a minus. And how many times do you move it? You move it once, twice, 3 times. So you know it's going to be 7.3 times 10 to the minus 3 in standard form. Question 7 tells us that a triangle has sides of 8 centimeters, 15 centimeters, and 17 centimeters. And we're asked to prove that this triangle is a right-angled triangle. So I've drawn a sketch here of how it should look like. And if it's a right-angled triangle, then Pythagoras' theorem should apply to it. So Pythagoras' theorem is a squared equals b squared plus c squared. So if we do a squared equals 8 squared as the b and 15 squared as the c squared, then a in the end should equal to 17. So a squared equals 8 squared plus 15 squared, which is just 289. So a squared is equal to 289. Now to get a on its own, we just do the square root both sides. So a equals the square root of 289, which is 17. So therefore we have proved that this is a right angle triangle because Pythagoras' theorem applies. Question 8 asks us to rearrange the formula to make x a subject in which y equals 4x plus 6. Okay, so here we're trying to make x the subject. So like question 1, we inverse inverse plus 6, which is minus 6. So do that to both sides. So 4x equals y minus 6. Now the inverse of 4 times x would be x over 4. So we do divided by 4, and then this also divided by 4. So our final answer is x equals y minus 6 over 4. And there we go, we've rearranged it to make x the subject. Question 9 asks us to solve the simultaneous equations of 2x plus y equals 14 and x minus y equals 1. So for this question, we're going to be using the elimination method. And how we'll do that is we'll add both equations together so that we can eliminate the y and get a value for x. So 2x plus x equals 3x. Y plus minus y equals, well, 0, so the y is eliminated. And then 14 plus 1 equals 15. So we know that 3x now equals 15. Then if we divide that by 3, both sides by 3, then we get x equals 5. Now we can substitute this x equals 5 that we now know into one of the original equations. So we'll do x minus y equals 1, because I guess that's easier. So 5 take away y equals 1. So what can you take away from 5 to get 1? Is 4. So y equals 4. And there we go, we've solved these simultaneous equations. Question 10 wants us to find the nth term of the sequence 3, 9, 15, and 21. Well, to find the nth term, the coefficient of n is going to be the difference between each number. And as this is a linear sequence, the difference is plus 6 each time. So the coefficient of n is going to be 6n. Now, as for the rest, well, it's just going to be what the number before 3 would have been. So if we do 3 minus 6, we know that it's minus 3. So minus 3 would have been in the sequence before 3. So the nth term is just 6n minus 3. Question 11 tells us that the probability of a spinner landing on red is 0.35. So P equals 0.35. And it asks us what is the probability that the spinner doesn't land on red. Well, we know that this 0.35 is out of 1. So what we do here is just 1 take away 0.35, which is 0.65. So we know that the probability of the spinner not landing on red is 0.65. Question 12 tells us that a shape has rotational symmetry of order 5, and we're asked to sketch or describe a possible shape for this. Well, what we can do is just a regular pentagon which can be drawn a bit like this. Obviously, this is just a sketch, so it won't be exactly how a regular pentagon looks. Question 13 wants us to simplify 3x squared y squared times 2xy. Now, what we could do here is we can just deal with each component of each term separately. So we can do 3 times 2, which equals 6, and then x squared times x, which equals x cubed, and then y squared times y equals y cubed. And now we just join this up as one term, so we get 6 x cubed y cubed as our final answer, and there we go, we've simplified it. Question 14 asks us to solve the inequality where 4x minus 1 is less than 15. So, like we've done previously in this worksheet, we're just solving the inequality for x basically. So we can do the inverse of minus 1, which is plus 1, and we'll do that on both sides. So 15 plus 1 equals 16. So now it's 4x is less than 16. So now we have to do the inverse of 4x, which is x over 4, to get x on its own. So over 4 on both sides. So 16 over 4 equals 4, and there we go. We've solved the inequality, so the final answer is x is less than 4. Question 15 tells us that a line has equation y equals 4x minus 2, and we're asked to find the gradient and y-intercept. Well, this is a straight line, as it's written in the form y equals mx plus c. And in this form, m, or the coefficient of x, is the gradient. And c is the y-intercept. So in terms of the original equation, y equals 4x minus 2, well, the coefficient of x, 4, which is m, which is the gradient. So gradient equals 4. And as for the y-intercept, it's just the c part, which in this case is minus 2. So the y-intercept is just minus 2. Question 16 asks us to calculate the area of a trapezium with parallel sides 9 centimeters and 7 centimeters and a height of 6 centimeters. So I've drawn the trapezium here, where we've got parallel sides of 7 centimeters and 9 centimeters, and I've displayed the height as 6 centimeters there. So we should recall what the formula for the area of a trapezium is, which is just a plus b over 2 times by height. And for a plus b, it's just 7 and 9. So if we calculate this, so a equals 7 plus 9 over 2 times by 6. So 7 add 9 just equals 16. And then 16 divided by 2 equals 8. So the area is just going to be 8 times 6, which is 48. So the area of this trapezium is 48 centimeters squared. Question 17 tells us that the volume of a cylinder is given by V equals pi r squared h. And we're asked to find V when r equals 4 and h equals 8. So if we write the formula, V equals pi r squared h. And r is 4, h equals 8. So if we work out, V equals pi times 4 squared times 8. And well, 4 squared equals 16. 16 times 8 equals 128. So pi times 128 is just 128 pi. So V equals 128 pi. This is the exact form. However, in a question, we may be asked to give the number in decimal form. So we actually have to work this out, and that would just be 128 pi, which we can input into a calculator. that just equals 402.12 to 2 decimal places. Question 18 wants us to rationalize the denominator of 6 over root 5. So 6 over root 5. And for rationalizing it, what we'll do is we'll multiply both the numerator and the denominator by root 5, so then we can eliminate that surd at the bottom. So if we do 6 times root 5 and root 5 times root 5, well, as for 6 times root 5, 6 times root 5 just equals 6 root 5. And root 5 times root 5 equals root 25. And as 25 is a squared number, the square root of 25 is 5. So the final answer would be 6 root 5 over 5. And there we go, we've rationalized the denominator. Question 19 tells us that a bag contains 7 red, 5 blue, and 3 green balls, and it's asking us what the probability of picking either a red or a blue ball is. Well, in total, there are 15 balls, there are 7 red, 5 blue, and 3 green. So, as we're working out the probability of picking either a red or a blue ball, well, the probability of getting a red ball is 7 over 15. Probability of getting a blue ball is 5 over 15, and green is 3 over 15. And we're working out the probability of picking either a red or a blue ball. So what we do here is we just add the probability of getting a red ball, which is 7 over 15, and we add that to the probability of getting a blue ball, which is 5 over 15, and that just equates to 12 over 15. And there we go. That is the probability of picking either a red or a blue ball. Question 20 asks us to use Pythagoras' theorem to find the hypotenuse of a right angled triangle with legs 9 centimeters and 12 centimeters. So first of all, we can sketch out this right angled triangle. This long side here is the hypotenuse, and we're trying to work that out. So we'll leave that as a question mark. And we know that the legs are 9 centimeters and 12 centimeters. Now let's recall what Pythagoras' theorem is. Well, Pythagoras' theorem is a squared equals b squared plus c squared. So a squared equals to, we'll substitute 9 as b, so b squared equals 9 squared plus 12 squared, substituting 12 as c. And well, when we put that into a calculator, we get a squared is equal to 225. That's a squared. However, we need to work out a. So we do square root on both sides, and a is equal to 15. So the hypotenuse, the question mark, we can now take out, and we know that this hypotenuse is now equal to 15 centimeters. Thank you guys for watching this video. We hope you enjoyed it, and leave a comment of what you want us to go through next.